in this session, we learned the total probability, which basically says, okay, so if I want to calculate probability of A, and I know this probability may depend on some possible events that can happen, I can potentially condition on those events. So for example, if this is my sample space, and let's assume here I can divide this sample space into two sections. I call one V, and the other one I can call anything, or I can just say B complement, or C or D, anything you want. But this is simply just B complement, which is basically anything in sample space S, which is not in V, then that is in the B complement. Okay. Now, I wanna let's assume I have an event here, and that this is my event A. Okay. Now I want to calculate what is the probability that A happens. So then I can condition the chance of A happening of knowing that either B has happened or B complement has happened. So then I can say that, okay, the chance of A happenings, if I know that B has happened, multiplied by probability of B, or plus, if I probability of A, if I know that B complement has happened, multiplied by probability of B complement. So basically I can do the calculations using this formula to find probability of A. And if I'm looking at scenarios when, let's say, the sample space S can be has been divided for some reason into further parts, let's say it's a part A, B, C, D. Obviously, as you can see, A, B, C, D, what is their characteristic? What can I say about A, B, C, D?
Partition.
They partition sample space S. Their condition is empty, and their union is sample space. So they partition the sample space. Now, let's assume I have this event. I'm going to call this event as G, let's say. And I want to find probability of G. Then I can write this based on the total probability rule. I can say probability of G if I know A has happened, multiplied by probability of A, or probability of G if I know B has happened, multiplied by probability of B, or probability of G if I know C has happened, multiplied by probability of C, plus probability of G if I know D has happened.
I think D is not included.
Sorry?
I think D is not included.
Yeah, it's not. That you are right. This is just a general formula. But then obviously, since when we look at this shape, we know that if D happens, if I know the event, the point I have picked, for example, is D, if I know that D has happened and the point is in D, obviously probability of G happening, then this whole thing will be 0. So basically in this specific example, this part, this whole thing will be 0. This part will be 0. And that's fine. But still, this is the general formula. I would always recommend to write the general formula, write the formula correctly. If some part of it is 0, then it's 0. You put 0 and you're fine. Okay, so that's total probability rule. That's a very, very important rule, guys, that helps us to calculate a lot of probabilities that we need to know. Because the thing is that sometimes the problem statements or the situations where we have to deal with are not as straightforward. So we have to really know these rules to still be able to deal with all those not easy situations and answer the probabilities. And then the second rule that we learned was the independence, which basically says two events are independent if knowing that one has happened has nothing to do with the probability that the other one happens or not. Okay, so if knowing that one has happened has no effect on the probability that another event happens or not, we call them independent. And in that scenario, for example, if A and B, let's assume these are independent, then probability that A happens and B happens, both of them happens, is just simply the multiplication of both. Probability that A happens and multiplication B happens. And we can write that for as many events as you. So if A, B, and C are independent, then A happens and B happens and C happens. It's just simply probability of A happens and multiplication B happens and C happens. They're independent from each other. So just multiply the probabilities together. So for example, here, let's assume this is A and this is B. Are A and B independent in this example? Meaning that knowing that the probability of one of them happening does not affect the probability of the other one happening or not.
I think no.
Yes or no?
No, because they are mutually exclusive.
Yes, they are mutually exclusive, meaning that they have no intersection, but they are not independent, meaning that I know A has happened, it has nothing to do with the probability of B happening or not. If I tell you I took a sample and I know A has happened, so the sample is somewhere in this circle, A has happened. What is the probability of B then? What is the probability that B has happened as well?
0.
It's 0.
No.
Exactly, 0, because I'm telling you, I pick a sample and I'm telling you A has happened. Then what is the probability that B happens? Is 0. Because depending on the shape, we see that if A has happened, it's somewhere here. It has no intersection, no overlap with B. So in this scenario, A and B are not independent because knowing that one of them has happened or not does affect the probability of the other one happening or not. So they are not independent. They are mutually exclusive, meaning that they have no intersection. Exclusive, meaning that they have no intersection, but that has nothing to do with independence. Independence means that knowing one event has happened or not has nothing to do with the other one. So make sure these concepts are clear for you guys and don't confuse them. So then let's look at an example. So in this example, we have a player of video games. And who faces 3 opponents in series, one after another. He or she has 80% chance of defeating each opponent. Then this is the question. What is the probability that the person defeats all opponents? Okay, so we want to answer that question. So there are three opponents: opponent 1, opponent 2, opponent 3, and this person has 80% chance to defeat any one of them. One other thing I need to tell you is that assume that the results, okay, this is important. Assume that the results from opponents are independent. Can someone tell me what does that mean? The results from opponents are independent.
So beating one opponent doesn't influence how you fight the other?
Exactly. Beating one, knowing that you have beaten one, has no effect on if you're going to beat the next one or win or lose. So independence always means knowing that one has happened has no effect on the other event happening or not. So this is an important piece of information. So if that's the case, then I want to know what is the probability that the person defeats all the opponents. So in that scenario, so the probability that defeat first opponent and defeat second opponent and defeat third opponent. So the and part is basically this part. And intersection. So then how do you write it? Defeating first opponent and second opponent and third opponents. And you know that these events are independent from each other. What was the rule of independence that we learned? Isn't this the rule of independence? This or this? Probability that A happens and B happens and C happens, you just multiply those probabilities. That's independence rule, right? So then how do you answer that here?
Will be probability of the first times probability of the second times probability of the third one.
Exactly. First one is defeated and the second one is defeated and third one is defeated. What is the probability that the first one is defeated?
80%.
0.8. Second one is defeated?
80%.
And the same for third one. So the result, whatever it is, that would be the probability of defeating the first opponent and second opponent and third opponent. Okay. Just simply because we know the results from opponents are independent from each other. So I could just write this as multiplication. Otherwise, I wouldn't. The next question, I mean part B of this question. What is the probability of defeating exactly two opponents? Okay, so as I said, we have opponent 1, opponent 2, opponent 3. Okay. Can you tell me the scenarios under which I can defeat exactly 2 opponents?
Like in words or in like
Yeah.
probabilities?
In words.
So you can defeat the first opponent and second, or first and third.
And then lose to the third one, right?
Oh yeah, my bad. Yeah.
And or what is the other scenario?
You beat the first and the third, but lose to the second,
Or
second and third, but lose to the first.
exactly. Okay. So these are the 3 scenarios where I can defeat exactly 2 opponents. I can beat first and second and lose to their last. I can beat the first and lose to the second and lose and beat the last one. I can lose to the first and beat the second and beat the last one. And I know the results of these games are independent from each other. So then, how do I calculate the probability? So then the probability is probability of this happens, or what is the right mathematical operation for or?
Union.
Plus. Yeah, so in the mathematics, it's a plus when we say or. So when we want basically the scenario 1 happens or scenario 2 happens, the probability of scenario 2 or, again, plus scenario 3 happens, this probability. So then, can you tell me what are the probabilities? Then what is the probability of scenario 1 happening? We win the first one, we win the second one, we lose to the last one. What is the probability that happens? Why are you not answering, guys?
It would be give me a sec. 12.8%.
No, just tell me the numbers, final numbers.
Oh,
I mean, not the final, just tell me what multiply by what then.
you multiply the 0.8 of the first one,
First one, we beat first one, and
the second one, which is 0.8 as well,
and
and 0.2 where you lose.
0.2, that's for first one, or the scenario 2. What is the probability of scenario 2?
0.8 for the first one again,
We beat
times
the first one, and
0.2 where you lose.
then we lose, and we beat the third one.
Yeah.
Or scenario 3 happens. And what is scenario 3 probability?
0.2 where you lose.
We lose and
Times 0.8.
we win.
And then again 0.8.
And then we win again. Okay. So the reason that I could put these multiplications, why I could put these multiplications to capture the ands. So for all these ands, these are the multiplications. And why I could do that? Simply because
Oh, Professor, how did you get the 0.2?
what is the, so if there is 80% chance of winning, what is the chance of losing?
Oh, okay.
0.2. So the reason that I could do these multiplications everywhere I saw and is simply because I know that the results of these games are independent from each other. So I can just say the results of the first one, multiply by the result of the second one, multiply by the result of the third one. Just simply I know, because I know the results of these games are independent from each other. and then obviously the plus to capture the or part. Scenario 1 happens, or scenario 2 happens, or scenario 3 happens. And this number, whatever it is going to give you the final probability of exactly beating exactly 2 players. We don't care if it's the first player or second player or third player, but beating exactly 2. Okay. Any questions so far? Okay. So in the next question, we are looking at a keyboard, a computer keyboard, a manufacturing facility for computer keyboards. And they have looked at the failures that can happen in these computer keyboards. So example 2. So we are looking at failure in computer keyboards. And they can have 2 main reasons. Some of them are electrical defects. Some of them are mechanical defects. 12% are electrical defects and 88% are mechanical defects. And okay, now out of electrical defects, of every defect that is electrical, are caused either by wire or by improper connection or poorly welded wires. And also we know that of all the electrical defects that we have had so far, 35% of them are because of the wires, 13% are because of the improper connections, and 52% are because of poorly welded wires. For mechanical defects, we know that either they are because of the loose key or improper assembly. And also we know that of mechanical defects, 27% of them are because of the loose key and 73 are because of improper assembly. So then, these are the questions I have. Oops. Find the probability that a failure is due to loose key. So we pick a failure, we pick a keyword, random keyword, and we look at its defect, with this defect, And I want to find what is the chance that this failure is because of the loose key. How do you think I have to write that, guys? So the probability of failure is because of the loose key. I'm going to write it as loose key. A loose key. Can I just say it's 27%? Can I just say that's the number?
It's 27 times 0.88, I think.
Yeah, I cannot say it's just 27% because it's 27% of the mechanical. So I have to first know if it's mechanical. Yes, then with the chance of 27%, it's because of the loose key. But here, I don't know if it's mechanical or not. Here, I just know that I want to know the probability of loose key. I don't know if the defects is mechanical or not. So if I'm going to use the total probability rule, I can say that this is equal to the probability of loose key if I know the defect is mechanical multiplied by the probability of mechanical plus probability of loose, the defect is because of the loose key if I know the defect is electrical multiplied by the probability of the defect being electrical. And I can definitely condition on being electrical or mechanical because these two basically partition the whole sample space. Every defect in this manufacturing facility is either in this category or in this category. And then they are divided into this lower level causes. But any defect that I pick is either mechanical or electrical. So then, what is this probability? What is this probability? Probability that the defect is because of the loose key if I know the defect is mechanical.
27.
27%
0.88.
multiplied by probability that the event is mechanical.
0.88.
Yes, 0.88. That's what I know here. Plus, what is the probability that the event is because of the loose key if I know the event is because of the electrical thing?
0.
That's 0. The electrical category has no loose key in it. So if I know that the reason is definitely electrical, then definitely is not because of the loose key. 0 multiplied by probability of being electrical, that's 0.12. So then the result is just 0.27 multiplied by 0.88, whatever it becomes. Okay. Any questions so far?
So we have to be careful with how the questions are, to where if it's general, we do what you just did. But if it's specific, say if it said it was mechanical defect, we can just go straight to the first part of it, right?
Yes, exactly. So if I just ask you, what is the probability that the problem is because of the loose key if I know that the event is mechanical, then you just do the simple conditional probability. So in this scenario, it's just simply the 27%. If I know that if it's mechanical, then it's 27%. But here, I'm not telling you, I don't know if it's mechanical or electrical. So then you have to condition on if it's mechanical or electrical. And the reason is that these other probabilities that you have, and because this is all you have, all you can use are these numbers. These numbers here are only thing you have to be able to multiply, add, do whatever to answer the questions. And pay attention that these numbers, you have these numbers under the condition of knowing if it's mechanical or electrical. So that also gives you a hint that if someone asks you, okay, what is the probability of Luski? You can't just answer the number. You have to condition on if it's mechanical or if it's electrical, because that's how you have the information. That's all you have. So you have to be able to know if it's mechanical or electrical, then pick these answers. If you don't know if it's mechanical or electrical, no problem. Condition on both. If it's mechanical or if it's electric. I want to know what is the probability that the failure is electrical and related to poorly welded wire. So I pick a keyboard that is defect, that has defects. I want to know what is the, and then I look at the defect and I want to know what is the chance that the defect is electrical and also is related to poorly welded wire, which is this part here, poorly welded wire. And I want to also make sure, also know the probability that is electrical and is related to poorly welded wire. Can I just simply say that, oh, this is and? I'm going to just say that this is probability of electrical multiply by probability of poorly welded wire. Can I write that? Like that? Which assumes, basically I'm assuming these two are independent. So I just write it as multiplication. Can I do that?
If they are independent, you can say that, or you can say probability of poorly welded wire condition given electrical.
Yeah, exactly. So the answer is that no, I cannot write it because the probability of poorly welded wire being the reason depends on if the reason is electrical or mechanical. If I know the reason is mechanical, so the chance that is because of the poorly welded wire is 0. But if I know the defect is electrical, then the probability of it's related to poorly welded wire is 52%. So these two are not independent from each other. The probability of the defect is because of the poorly welded wire depends on this other one, if I know if it's electrical or not. So they're not independent from each other. I cannot write it just as a simple multiplication or write like this. I could write it if they were independent from each other, but they are not. Knowing the probability of one affect the probability of other one. So they're not independent. So if you remember multiplication rule,
Yes.
from previous session, can you tell me how I can rewrite this probability?
Probability of poorly welded wire and do
you remember the multiplication rule when we said probability of A and B? How do we write this? Probability of
A given B
condition B multiplied by
P of B.
And we can rewrite it one more way. Can you tell me that one? Knowing that A and B are the same as B and A. They have no difference. You can move them around, they are the same. I can also write this as probability of B condition on A multiplied by probability of A, right?
Yes.
So probability of A and B and A, they're the same. Okay, so A and B is the same thing as B and A. A union B is the same thing as B union A. So just keep that in mind as a side note. So for probability of A and B, I can either write it as probability of A condition B multiplied by probability of B, or let's assume this is B and A. In that scenario, I can write it as probability of B condition on A multiplied by probability of A. It doesn't matter. However, this is the question. This is the situation. You pick the way that works for you depending on the problem that you have, that you're looking at. Which one of them is the one that you want to pick? The ones that works for you. Let's look at how this happens here. So here, tell me 2 ways I can write this. I can rewrite this. One of them is probability of poorly welded wire condition on
Electrical
is electrical
times probability of electrical.
multiplied by probability of electrical. What is the other way?
Probability of electrical
Probability
given
of electrical
wire
condition on
poorly welded wire times probability of poorly welded wire.
welded wire. Obviously, poorly welded wire. Okay. I'm going to just erase this part so that it doesn't confuse. Okay. So both of these are correct. I can either write it this way or this way. Both of them are correct. The question is that which one of them is the one that you have to pick? Can you tell me which one and why? Given the fact that this is the problem statement. These are all your, these are all the things you have that is given to you. Which one of these 2 is the one that you can pick in this problem?
I think the second one, because the poorly welded wire is like given information.
But given what we have at the top, can you just simply tell me what is probability of being electrical defect if I know it's poorly welded wire? Do we have anything like that?
No.
What I have on the top says if you tell me it's electrical, then I can tell you what is probability of poorly welded wire, which is the first one. If you tell me it's electrical, then I can tell you what is the probability of poorly welded wire. And I also have the probability of being electrical here. So we're good. If I pick the second one, I don't have this part readily available. I do not have this part readily available. So I have to do just a bunch of calculations. But if I pick the first method, I have all the components in the problem statement. So I'm good. Okay. So then here, we are going to pick the first method. So we are answering this based on the first formula. So what is the probability of poorly welded wire given the fact that the defect is electrical? Here. If the defect is correct electrical, what is the chance that it's poorly welded wire? 52%. Right? If I know the defect is electrical, then 52% of them are because of poorly welded wires. So that's 0.52 multiply. What is the probability of being electrical defect? We know on the top that out of all the defects, 12% of them are electrical. So that's then the number, whatever it's going to be. Okay. Any question? Go ahead.
Well, no, I was just going to give the answer for the 0.2 times 12.12.
0.2.
Oh, no, it's a 0.0624.
Thank you. Yeah, so these are basically some examples related to the problem. And as I said, these are all like different formulations for rewriting something that you want to calculate. This is what you want to calculate at the end of the day. But you don't have this probability right away given to you. So all these rules, total probability, multiplication rule, everything we learn is basically to find out how I can rewrite this based on the information that I have in the problem statement. So I can then plug this information and find the value of this probability. So for scenarios where you have to calculate something and something else, the probability of an event and another event, and if you know they are not independent, obviously, as I said, if they are independent, easy, just multiplication. If they are not independent, always multiplication rule is the one that helps. And in multiplication rules, as we just said, we can always write probability of A and B in the multiplication rule. I can always write this in two ways, either probability of A condition on B or probability of B condition on A. Which one is the one that you have to pick? Look at the problem statement. See which one of these informations you have, then pick that one. If you have this information in your problem statement, pick that one. If you have this one readily available in the problem statement, pick that one. And then just replace and find the values.